Today I am presenting here the lecture on the topic entitled IR spectroscopy and its applications, which is useful for B.Pharm 7th semester in our instrumental methods of analysis BP 701T in unit 2nd. It is also useful for M.Pharma in MPC 101 and instrumental methods of analysis. In previous lecture, I explained the basics of IR infrared spectroscopy, instrumentation of IR spectroscopy and theory and its principle. The structure of new compounds that are isolated from natural resources are prepared in the lab must be determined and are verified by chemical analysis and spectroscopy. The spectroscopic techniques are non-destructive and generally require small amounts of sample. IR spectroscopy is based on absorption of IR radiation by a molecule which cause stretching, bending and motion of chemical bond. IR radiations has three regions, which I already explained in previous lectures. The IR region is divided in three parts. One is near IR, in which the 12,800 centimeter to 4,000 centimeter inverse absorptions are there, and in middle IR 4,000 centimeter inverse to 200 centimeter inverse, and in far IR 200 centimeter inverse to 10 centimeter inverse, and mostly used IR region is 4,000 centimeter inverse to 670 centimeter inverse. The amount of energy that's required to make the bonds wet, dance and twist, it is depend on the type of bond. And here the examples of the bonds and their energy which absorb the molecules. For example, the ethanol, and this is the after absorption of the molecules which are showing the like dance or wag or twist like in natures, like IR radiations with initial intensity of I0 enters through the sample, and after passing through sample, IR radiation is absorbed by sample and the intensity of IR radiation is decreased to I. What's an IR spectrometer? The IR sources produce consistently infrared radiations because the fluctuations can be mistaken for sample absorptions. Liquid samples are usually placed between two flat crystals of sodium chloride like salt pellets, and sodium chloride is used because it doesn't absorb light. Solid samples are often mixed with potassium bromide and pressed into a pellet. The potassium bromides like sodium chloride also doesn't absorb light, IR light, in the wavelengths of interest. The detectors which measure the light that comes through the sample, and computers present the spectrum on a printer and on computer screen. And applications of IR. The main applications of the qualitative analysis and quantitative analysis of IR. In qualitative analysis, the compounds identification is must, like functional group analysis. The main application of IR is and use of IR with NMR and mass in late 1950s revolutionized organic chemistry and decrease the time to confirm compound identifications, which is 10 to 1000 fold, and in general schemes which they examine what functional groups are present by looking at group frequency regions, regions like 3600 centimeter inverse to 1200 centimeter inverse. And this region is mostly used in functional group determinations like carbonyl group, carbon-carbon double bond, CO stretching, OH stretching, and others group. This is the spectra of IR spectrum, and in x-axis represent the wave number in centimeter inverse, and this one is the absorptions of IR. This is the colors absorptions in IR rays, which is visible regions. In group frequency regions, the approximately frequency of many functional groups like C11O, C11C, and C1H and OH, which can be calculated from atomic masses and force constant. The position changes a little with neighboring atoms, but often in sample general region, and which serves as a good initial guide to compounds identity but not positive proof. The regions which shows the OH stretching NH, CH and their regions, and C, carbon, nitrogen and oxygens, and carbon-carbon single bond, CO stretching and CN. This is showing the bending vibrations, stretching vibrations and other rotational vibrations are take place. This is the table which describe the group of frequencies for organic groups and their bonds, and the frequency which is absorbed and the given intensity. First one is the CH, and compounds like alkanes which is absorbed and 2850 to 2970, and it gives the strong band. And another compounds like alkene, C11C and CH stretchings, and the frequency region is 3010 to 3095, and it gives the two peaks, and another peak is 675 to 995, and this gives the medium and strong intensity band. And another compound is CH, which is involved in alkynes group and which absorb in 3300 centimeter inverse, and it gives the strong intensity band. And CH stretching in aromatic ring, and this showing the two peaks and 3010 to 3100 centimeter inverse, and another peaks is 690 to 900 centimeter inverse, and strong and medium band, intensity band. And OH stretchings and monomeric alcohols like phenol, hydrogen bonded alcohols, phenol. In monomeric alcohols and phenol, which is absorbed in 3590 to 3650 and variable intensity peak, and hydrogen bonded alcohol and phenols, and which is absorbed in 3200 to 3600 in variable and sometimes in broad spectrum. And monomeric carboxylic acids 3500 to 3650 centimeter inverse and medium intensity peak, and in hydrogen bonded carboxylic acids which absorbed in 2500 to 2700 centimeter inverse, and it gives the broad band of peak. And another examples like amines or amide, and then NH stretching is showing in 3300 to 3500 centimeter inverse and medium intensity peak. And next one is alkenes like C11C bond is absorbed in 1610 to 1680 centimeter inverse in variable peak. And the next example is aromatic ring in C double bond C bond, which is absorbed in 2100 to 2260 in variable peak. And next example is amines or amides like CN, which is absorbed in 1180 to 1360 centimeter inverse and strong intensity peak. And next example is nitrile like C triple bond N, which is absorbed in 2210 to 2280 centimeter inverse in strong intensity peak. And carbonyl group are CO, alcohols, ethers or carboxylic acid or esters, which is absorbed in 1050 to 1300 centimeter inverse in strong intensity peak. And next example is aldehyde ketones, carboxylic acid, esters, which absorb in CO, C double bond O, and in 1690 to 1760 centimeter inverse in strong intensity peak. And then last one is the nitro compound NO2, and this gives the two peaks in 1500 to 1570 centimeter inverse and 1300 to 1370 centimeter inverse in strong intensity peak. Third region is the fingerprint region, which is showing the 1200 to 700 centimeter inverse absorptions, and the regions of most single bond signals. The many have similar frequencies, so affect each other and give pattern characteristics of overall skeletal structure of compound. Exact interpretation of this region of spectral seldom possible because of complexity. The complexity is the uniqueness, and this region is showing the fingerprint region, and this is the examples of the carbonyl group. Fourth, the computer searches. The many modern instruments have references IR spectrums on file, one lacks compounds and matches based on location of strongest band, then second strongest band, etc. Overall skeletal structure of compound, the exact interpretation of this region of spectra seldom possible because of complexity, and this is showing the uniqueness of the spectra, which is the upper side, which is shows the high quality hit, and the lower side, which is showing the low quality hits of spectra. And in quantitative analysis, not as good as UV visible in terms of accuracy and precision. The more complex spectra and narrower bond like Beer's law deviations, and the limitations of IR instruments is the lower light throughput and weaker detectors, high background IR, and difficult to match the reference and sample cell. Change in absorptions common, and potential advantage is good selectivity, since so many compounds have different IR spectra. One common application is determination of air contaminants. The table showing the air contaminants like carbon monoxide. The standard value of the concentration of carbon monoxide is 50 parts per million, and it is found by IR in 49.1 parts per million, and the relative error is observed in 1.8%. And others contaminants like methyl ethyl ketones, which is showing the 98.3%, found ppm, and relative error is found 1.7%. And next example is methyl alcohol, which is found in 99 parts per million, and 1% error is obtained. And ethylene oxide, which is showing the 49.9% found in concentration, and 0.2% error is found. Next example is chloroform, which is found in 99.5 concentration, and relative error is found in 0.5%. This is the examples which is showing the IR spectra of the compounds. The spectrum is of substances with the empirical formula of C3H5N, and what is the compound of this? And their first one region is the aliphatic hydrogen, showing this the spectra, and the next is the nitrile like alkyne group, which is also showing this spectra, and this region is showing the no aromatics, and the last one is the one or more alkene groups are there in these regions. And this is the example of some spectra which is determined by the IR. And thank you.